Hello, good morning everyone. I hope everyone's joined and there's no issue. So today the topic for online training is patterns. Like we are all using patterns at part level and as well as in assembly level. So generally we use the linear and circular patterns. We'll just today see in-depth analysis and see all the options concerning all the patterns that are used in SolidWorks. So as we all know, part level patterns, there are like 8 patterns available. Linear pattern, the circular pattern, you can mirror components, can have a sketch-driven pattern, curve-driven pattern, table-driven. Likewise, we have 8 types of patterns available in at the part level in SolidWorks. So we'll just begin by creating a linear pattern. We'll see how it goes. Almost everyone must be knowing what linear pattern is. So we'll just see step by step what it actually does and all the functions involved in the linear pattern. So I've just created this simple rectangular plate with an extruded cut section over here. So I have to create a linear pattern of this section. So we can find the linear pattern option right at the features tab over here, or you can even find it from insert patterns. I'll just click the linear pattern. So I have to pattern this feature, the cut feature. I can directly select it from the graphics window itself or from the feature manager design tree. So in the features, I'll select cut extrude. For direction 1, so I can specify the direction. It can be a line, it can be an edge, or it can be a sketch line. So for direction 1, I'll just select this horizontal edge. You can just give the spacing and instances, the distance between those instances. For example, I've set this distance to say 20 mm, and I'll keep the number of instances to 5. Similarly, for direction 2, I'll select this vertical edge and I'll give the same spacing and number of instances. Just reverse the direction. So the spacing is quite, a bit significant. I'll just reduce the spacing to say 15 mm. That get a closer sort of pattern. So this is the basic linear pattern which all of us know that we are doing. We'll see all the properties that we might not be using the day-to-day designing work. For example, let's just start with the pattern seed only option. So as I click this pattern seed only, you can see the change. It just patterns the seed in the second direction. So the pattern seed only option is only available in the direction 2. When you just activate the direction 2 option, you have the option to pattern just the seed, or by default it is ticked off. So all the patterns, like the number of instances, if I selected 6, so all those 6 instances will be patterned in the direction 2 as well. So that was pattern seed only option. Just say OK. And here you can see the cut section has been patterned in a proper way. You see more options with the linear pattern. Here you can see the property manager. There are spacing and instances. One by one, we'll see all the options and how it affects our design. First and foremost, we'll just see what instances to skip does. So I'll just go to edit feature. And right at the bottom, you see instances to skip option. So here I can just click on few instances which I don't want in my pattern, and it will be skipped from my pattern instances. Another option in linear pattern is to propagate the visual properties. For example, this cut, I have given the red color for this cut. So if I clear this option, the extrude cuts will be without the visual appearance that was applied to the cut extrude. So I want to apply the particular appearance as well in the pattern. I'll just use the option to propagate visual properties. So as spacing, you can determine your instances. You can specify your patterns by either giving the number of instances and the distance between them, or you can select up to reference. So the up to reference is an option where you can select a vertex or an edge. So the pattern will automatically be the instance up to that particular reference. For example, if I select this edge and I can set the offset distance from that edge. Currently it is 0. I can specify the spacing that I want between the instances, or I can just input the number of instances that I want. So if I input 5, irrespective of the distance, it will just try to create 5 instances within that particular dimension. Similarly, you can use the up to reference option in the direction 2 as well. There are some other options as well, which I guess which are very helpful in using patterns, and it can really help to create complex patterns as well. So we'll see one option called the geometry pattern. Just skip to geometry pattern. So I have this cut section, cut extrude created in this part. I'll just take you to the property manager of this cut extrude. Here you'll see I have selected offset from surface and I've kept the offset to 5 mm. So when I use linear pattern on this, you can see I have set the spacing to be 25 and the number of instances 6. Below, by default, the geometry pattern is off. So in the preview section, you can see it is following the 5 mm offset continuously. So all the patterns, all the instances are being patterned with respect to this 5 mm instances. If I click this geometry pattern, it will only pattern this seed. So whatever the dimension of the parent cut feature is there, it will just pattern accordingly. It will just neglect the 5 mm offset distance. And also the rebuild time is greatly reduced by using the geometry pattern. can see the difference. If I click this option off, you see the cut throughout the section. Similarly, there are two more features wherein you can vary your instances, your parent feature. Namely, we'll just first see what vary sketch does. If you notice in a normal pattern, when you're patterning, so suppose I've created a linear pattern on this. This is the property manager. Here below you can see that by default, the vary sketch option is grayed out. So this option will only be available when you have selected a proper direction. I'll just give an example for vary sketch. We'll see how vary sketch affects the pattern. So here I have created a slot at a 35-degree angle. I have not given the dimension for the length because I want that dimension to be varied across the cross section. So I have just given the dimension for the vertical sort of distance of the slot and the horizontal distance, like this 10 mm and 10 mm. So we'll see what vary sketch does. Once you see the example, you'll get to know. And this dimension, this is a very important dimension in vary sketch. This 20 mm from the corner point. This is the dimension which we'll be using for patterning. So I'll just select linear pattern, and in the direction column, I'll select this 20 mm dimension. And here below you can see the vary sketch option is now available. I'll just click vary sketch. In the features and faces, I'll select this cut section. And here you can see, irrespective of the length of the slot, it is maintaining the distance that the slot has from X position and Y position. That is this 10 mm distance, it is maintaining along with the 35-degree angle. So we have not given the length. We don't need to give the length for this in this type of case, wherein we need to pattern with the vary sketch option. So here you can see the slot length keeps on increasing. Spacing we can adjust accordingly. So if I add one more instance, it will go out of the particular part, so which we don't want. So that is the reason why we have kept the number of instances to be 5. You have any sort of queries, or during the presentation you feel like you're not understood a particular thing that I'm saying, you can just type in the chat section, or if you have any doubts, we'll have a Q&A session at the end of the webinar. So vary sketch option we have done. Similar to that, we have instances to vary. So this is a bit of an extension for varying our patterns. So we'll see an example for instances to vary. So this is the particular cut section we want to pattern. So we'll see what instances to vary does. I say linear pattern. Select my cut extrude. In the direction, I'll just specify my horizontal direction 2. vertical edge, give the spacing as say 20 mm, increase the number of instances. Similarly, in the vertical direction as well, I'll just increase the number of instances, keep the spacing to 20. So as you scroll down, you can see there is an option for instances to vary. You just need to take it off. And the first column that you see is direction 1 increments. So what it does is, if I enter 1 mm over here, so the increment that you see, we have set the spacing to be 20 mm. So as the pattern goes on, it will just increase the spacing between them by 1 mm. If I want to decrease the spacing, I'll just say minus 1 mm. Here in this box, I can select the feature dimensions which I want to vary. For example, for this cut section, the diameter of this cut section is 15 mm. So I'll just select this dimension. And if I want to increase that dimension, I can just input as 1 mm. For this instance, I want to decrease this dimension by say 1 mm or say 0.5 mm. And similarly, I'll select this depth option, the depth of cut, and again I'll specify minus 0.5 mm. As you can see that change, you can see in the preview section, as the pattern goes on, the diameter is being reduced. I'll just, for a better clarity, I'll set this increment to minus 1 mm. Here you can see as the pattern goes on, the diameter of the pattern is being decreased. Similarly, in the direction 2 option, we can set the increment. So vertically as well, there will be a decrease of minus 1 mm between the patterns. Similarly, I can choose the feature for this, the dimensions which I want to vary with this, and the depth option. And I'll reduce it similarly by minus 1 and minus 0.5. So here you can see as the pattern is being created along the X and Y direction, the dimensions are being varied. Click OK. So this is the result that we get. So initially the cut was 2-1. So as the pattern went on, the depth of cut went on decreasing. There are some more options available in instances to vary. So I can even click any instance. You'll see a couple of options over here. If I click skip instance, it will just skip that instance. I want it back, I just click it and unskip instance. If out of all of those instances I want to modify any particular instance, I'll just click that, modify, and I can change the dimension of that particular instance from here. So it is very customizable, where you can just, along with creating a pattern, you can specify customized sort of dimensions to your particular instances which you want your particular dimensions to be. I'll just click and modify over here. See, I just modified the dimension of this particular cut section. Below here, you can see the modified instances and just clear it if you don't want that modification, and it will return to its original. All the properties of the linear pattern, we have almost covered everything. The instances to skip, the instances to vary sketch, geometry pattern, and propagating visual properties. One thing, I guess, so here I've selected some features to pattern. So if you have certain bodies to pattern, so instead of features, you can select those particular bodies in this dialog box. So when there is a particular body to be patterned, and if you're trying to use the features and faces, the linear pattern will give you an error. So instead, you can just use the bodies column to pattern the particular bodies. So as I mentioned, the pattern seed only options. Here's a visual difference for you. With pattern seed only, the left hand side image is when pattern seed only option is on, and the right hand option is when by default it is checked off. So we have seen the linear pattern. Similarly, we see the circular pattern as well. So circular pattern, as we all know, if I want to create a circular pattern of this cut extrude, there is a drop down arrow over here. Here you can select circular pattern. For direction 1, I can either specify any axis if I have no axis of this cylindrical component, or I can specify this circular edge as well. The options are almost similar to what we have seen in a linear pattern. In the features and faces, I can select the cut extrude. So here there are two options. Either I can specify the degrees to which I have to pattern, and number of instances. So if I specify 8 instances with 30 degrees, you see the spacing between them to be 30 degrees, and 8 number of instances will be patterned. Or I can select the equal spacing option, and depending upon the number of instances, it will automatically be divided in the 360-degree phase. So as I increase the number of instances, the patterns are getting closer. So in the circular pattern option, there's this direction 2 option as well. So for example, I've created a 30-degree pattern of this cut section for 4 instances. If I turn on the direction 2, there's an option for using symmetry. So if I click symmetry, all the particular patterns that we have created in the direction 1, you'll see a symmetry of that in the direction 2 as well. Or you can specify your particular instances. For example, if in the direction 2 I want the instances to be 5. So here you'll see 5 number of instances in that particular direction. Or even I can set equal spacing for it. For equal spacing as well, if I want to set 180°, so it will divide the instances in 180° only. Accordingly, I can set any angle and it will divide the number of instances within that particular angle. Similarly, instances to vary, you can use the same option in the circular pattern as well. Direction increments here, instead of the linear dimension, you have the dimension of the angle, and just change the angle by say 2°. Change the dimension to 20 mm, and just I'll reduce it by -1 mm for every increment. Similarly, you can select the depth of cut as well. So here you can see the preview. As the pattern goes on, the dimension is being reduced. I can also increase the dimension if I like. As I increase the instances, here you'll see the pattern goes on decreasing. The diameter of that pattern goes on decreasing. So this is the result that we get. So instances to vary is a great option to use along with patterns, just to use some of the modification tools that we have in the pattern section. Moving on, after completing the linear and circular pattern, I hope everything is clear. If you have any doubts, you can always ask in the chat section, or also in the Q&A section at the last. So moving on, we'll just go to the further patterns that we have. So next up, we have curve-driven and sketch-driven pattern. So we'll see how curve-driven pattern is used. So here I have a simple boss extrude created, and I've just used a cut section to just remove this particular portion, so I get a proper curve face. So if I want to create a pattern on this particular face, so we'll see how it is done. So first up, I'll just create a sketch on this particular plane because it is at the center of that face. So if your front plane is not at the center, you can always create a reference plane. So I have this front plane at this section, so I'll just create a sketch on it. And I want to use this curve, so I just select and use convert entities. So as you can see, this curve has been created. So I want to create a particular boss extrude or any particular feature on this curve or on a particular point of that curve. For that, I'll just create a point on that curve so that we can create that particular feature on that point and use the curve-driven pattern accordingly. So below this reference geometry, you'll see there's an option to create a point. I'll select point. The selection, I'll select this particular edge, and I can specify the distance from the curve. So this is the distance along the curve from this point, the starting point of that curve. I'll suggest 25. I've created a point on that particular curve. Now I want to create a boss extrude on this particular plane. For that I have to create a plane so that I can create that boss extrude in a particular direction. So we'll just see how that is created. I'll go to reference plane. For first reference, I'll select this edge. And for the second reference, we'll just see if it. Okay. So instead of that curve, I have to select this face so that it is tangent to that particular face. And for second reference, I select the point. So you can see a tangent plane has been created, which is coincident to the point which we created. Say OK. And I'll create a sketch on this particular plane. Or randomly, I'm just creating a circular boss. Just keep the distance to 10 mm only. So this is the boss extrude which I have to pattern, and I'll use the sketch that I have created to pattern this along the curve. So here you'll see below the linear pattern option, there is an option for curve driven pattern. So automatically in the direction 1, the sketch has been selected, or as there's a new body created, I'll select body instead of features. So in the preview section itself, you can see how the pattern has been created. So there are a number of options available in the curve driven pattern. First of all, we'll see what this alignment method does. So by default, it is tangent to curve. So as the curve goes on, the feature will be tangent to that curve. So if I select the align to seed option, it will just keep its position, the position that the parent boss feature has. It is not rotating according to the curve. And if I select tangent, here you can see the pattern is along with the curve, it is changing its position. Here is another example I would like to show you, so that we can just see what the difference is between transform curve and offset curve. See, here you can see the tangent to curve option and the alignment, tangent and align speed. We saw the difference that it does to the pattern. Now we'll see, I just created a cut section over here and have this curve. So we can pattern by using this particular sketch. I'll just firstly create a sketch and use this curve, say convert entities. I'll go to curve driven pattern. In the direction, it is automatically been selected. The sketch. In the features, I'll select this cut section. So there are two methods of patterning in a curve driven pattern. One is the transform curve. Here you can see the curve, it follows the path of the curve irrespective of the distance between the curve and the parent feature. So it doesn't maintain the distance, it just follows the curvature. And if I see the offset curve, it will maintain the distance between that particular curve. So here you can see that distance between the center of this cut extrude and the curve is being maintained. And in the transform curve, the delta x and delta y distance from the starting point is being maintained. So these are the two methods that we have in the curve driven pattern. So there's one more option in curve driven pattern, that is face normal. We'll see an example for that. I'll just create a helix for that. Below here, curves, I'll select helix. And I can specify pitch and revolution. I can select the method that I want. I'll just select height and revolution. Specify the height as 100. And I'll set the number of revolutions. Five for time being. And similarly, I'll just create a cylindrical boss. The same diameter. I'll use extrude. The reason why I'm doing this, I can show you what the face normal option does. So here I have created a cylindrical boss along which has a spiral, helix and spiral curve around it. So I'll just create a plane at this particular point, the starting point of my helix, so that I can create a parent feature on that particular point. Selected the plane, I'll just create a sketch on it. Keep the extrusion say 5 mm. So I know it has been, half of the portion has been inserted inside. It doesn't matter, we just need to see how the face normal option works in curve driven pattern. In the curve driven pattern, for the direction, I'll select the helix. And for features, I'll select a boss extrude. and I'll use face normal, select this face. So just ignore the type of extrude that we have done. What we need to understand is how the feature has been patterned along the helix spiral and what is the use of face normal. I have selected this face normal, this cylindrical portion. So as I increase the instances here, you can see it is going along the spiral direction, the spiral curve which we have created. So by using this face normal option, we can create this type of curve driven pattern as well. On we I just think we forget the mirror option. I'll just quickly tell you what the mirror option does. So for mirroring, you can mirror particular features or particular bodies. Example, I have to mirror this particular body. I'll just select, I can either select a plane or I can select a particular face. So if I select this face, so in the bodies to mirror option, I can select which bodies I have to mirror. So currently there are 7 bodies. So accordingly, I can select which body I have to mirror. Select all, or I can just select the instances that I want. So below here, there are options to merge your solids. So you can create one particular solid if you select the merge solid option. In this example, it is not possible, it will give an error because we have certain bodies which are far away from the other body. So we'll just deselect this option. And see, I've just selected this body and this particular body, and it has mirrored along the vertical face. So moving on, we'll see after curve-driven pattern is done. I guess everything is clear. We'll see what sketch pattern does. I just create a geometry for it. I've created a simple rectangular boss and just create some feature so as to use it in the pattern. So I just create a slot cut. I'm not giving any dimension. You just see how the sketch pattern works. So I want to pattern this particular cut using the sketch pattern. So the first thing that we would like to know about sketch pattern is you need to create a sketch for it, and can the sketch can contain anything, but the feature will take only the points for consideration. So I'll just start a sketch and I'll create random points at some positions. So if I create any center line, I can create center line as well, just to give some dimensions to it. I can just randomly create points wherever I want. So I've just created a point sketch for reference, and I'll use a sketch driven pattern. So automatically over here, you see there's a reference sketch option. So the sketch which we created now, you have to use that particular sketch over here. We'll see what the reference point does. So in the features, I'll select the particular slot, and here you will see the location where we have created those points. We are getting the particular slots. So what reference point does is, by default, it is selected centroid. So in the preview option, here you can see as it is getting pattern, it is being referenced by the center point of this slot. I can select my own point as well. If I want any particular point, if there's a rectangle involved, if there's a complex geometry, for example, I'll just keep this as it is, and I'll just change my slot sketch and insert a rectangle instead of it. So here, as you can see, it is taking the centroid for reference. I'll use selected point, and here you'll see the difference. As I select a corner point on the right hand side, the way the pattern has been oriented has changed. I select another point. So according to this reference point, the pattern, the instances has been changed. By default, it is set at the centroid. And rest of the options are just similar to what we have done in the linear and circular pattern. The only thing to remember in this sketch pattern is that you have to create a sketch with points in it. This particular feature only takes into considerations these particular points and no other instances. So if you have a sketch with points, then only you can use that sketch driven pattern, and accordingly and have that instances pattern. So here you can see the difference between the reference point and a particular vertex used as a reference point. Here you can see the change in the pattern. Moving on, there are 3 more patterns. At the part level, we have table, fill, and variable pattern, which is, I guess, least used by everyone. I guess most of the designers will not be knowing about it. So we'll just see what table, fill, and variable pattern does. Firstly, we'll see what table pattern, how it works. Just delete this particular instance. Give some dimensions that will be used in our table driven pattern. Just give dimensions to my rectangular slot. So we'll create a pattern of this slot using table-driven pattern. We'll go to table-driven pattern. So here you'll see a small dialog box being appeared. So the first option is read a file from. So I can create a text file with all the coordinates. We'll see how it is done. So one of the important things of table-driven pattern is you need a coordinate system. So before I create a table-driven pattern, I need to create a coordinate system which can be used over here to specify the coordinates. So just we'll create a coordinate system and select the origin to be this point. We want x-axis. Change the direction of our y-axis. We'll keep this edge. Change the direction. We have created a coordinate system and we'll use this coordinate system in the table-driven pattern. We'll go to table-driven pattern. So automatically here you will see the coordinate system has been selected. In the features to copy, I select boss extrude. So here you will see a small table over here. So if I don't have a text file, I can just input my x and y values. For example, I'll just increase the x value to say 50, the y value same, similarly 75, 100. On the right hand side in the graphics window, you can see the preview. As we are entering the coordinates, it is creating that particular pattern by using the reference of the coordinate system which we created. So these particular distances are from this particular edge. Similarly, we can keep the x distance same and increase in the y direction as well. So in this way, you can use a table-driven pattern by just specifying the coordinates, the xy coordinates. Similarly, instead of manually inputting all those values, I can just create a text file. You just say a new text document. So here, what I need to do is just input all the values which we now inserted in the table. Example, I'll say 25, 50, 55, 75. I just need to input those XY values with a comma, nothing else. It will automatically read the text document. I'm just inserting some random values. Now just save this file. So now, instead of this patterns, I'll select my particular file. I'll select the text file option from this. So here you can see it automatically reads the data from the text file. And all the coordinates which we have entered has been presented below over here. Say OK, and according to the coordinates which we have entered in the text document, we'll get a pattern particular to that. So one important thing to remember is you have to create a coordinate system for a table-driven pattern. You can use a text file for inserting all the coordinates, or you can directly enter all the coordinates in the table as well. So again, the difference between reference point and centroid, as we saw in the previous example, how the pattern changes according to the reference point. So here you can see there are two examples where in the left we have selected a corner reference point, and accordingly the coordinates has been using that corner reference. And on the right we'll see the reference point is centroid. So whatever coordinates we are giving, it is taking the reference of the centroid. Moving on, we'll see fill pattern. Fill pattern is mostly used for creating perforations. I'll create some sketch. And I just want to create some holes on this circular boss. So for pattern, I'll just create a parent, the type of hole that I want. For example, I just want a simple, say, straight slot. Just create this slot at the origin itself. I've just created a random sketch. We'll create a cutout of it. So we'll use fill pattern and let's see what it does. So as we open, click on fill pattern, you see the property manager of fill pattern. First and foremost, you have to select the fill boundary, the boundary on which we have to create the fill pattern. So just select this face, and if I've created a feature, I can select that feature. For example, I've created this slot. I'll just create this, select this slot, and there are a number of pattern layouts available. Perforation, the circular, and there are a number of options to adjust the spacing, the angle of that particular instance. So for a better understanding, we'll just change our sketch to a bit simpler one so that I can explain you the options involved in it. We'll go to fill pattern, select the boundary, select the feature. When there is some glitch, I'll just check. There is a, I guess, some issue in it. It is not showing me the preview. Just try and create this part again. So let's just try again the fill pattern. Select the fill boundary. And the selected feature. I'll select Mecca texture. So here you can see there are types of pattern layouts available. The first one being perforation, and there are a number of options available. You can set the spacing between them. You can set the angle. If I set it 90 degree, you get a linear pattern sort of. I'll just set it to again 60 degree. I can set some margins. Example, if I set my margin to 2 mm, by using margins, the boundary of that particular fill, can set margins. So there will be a gap of 2 mm or whatever margin you set. So here you'll see if I set minus 8 mm, it is going above that. I'll just say 2 mm. So automatically, I'll say a better say. So automatically, there's a gap of 5 mm. So this might be more than 5 mm because if we create one more instance of that pattern, it will just the margin for 5 mm will not be applied. That is the reason why it has just kept one more instance so as to maintain the 5 mm margin. Changing the pattern layout, you will see this circular pattern as well. And again, there are a number of options available. You just select particular margin, the spacing. So likewise, there are these 4 types of layouts available. The validate count option checks whether all the instances that are being created are within the fill boundary itself or not. So one more option, this is an interesting option in fill pattern. So what if I have not created my cut section? I have to create a fill pattern, a perforation sort of design I want to create. So I'll just select fill pattern, use my boundary, select any of the pattern layouts, and instead of selected feature, I'll say create seed cut. So in the seed cut option, there are 4 types of geometries available. You can create a circular cut, square cut, and there are polygon as well. So with different types of cuts, there are different dimensions. For example, for the circular, we have the diameter. You can set the diameter for it. The sketch point you can set, and accordingly, there are a number of options available as we select different types of cuts. So rather than creating a particular feature and then using the pattern, you can directly just without creating any sketch and pattern, you can directly use the fill pattern and create your desired perforations. So the last pattern in the part level patterns is the variable pattern. We'll see an example of a variable pattern. So with variable pattern, I'll just show you. I've created this particular slot, given some dimensions and fillets as well. So we'll see what variable pattern does. It is just a bit similar to instances to vary. As I click on variable pattern, I can select the features that I want to pattern. From the feature manager, I'll select the boss extrude and the fillet, and I'll say create pattern table. So here you can see there's a table being created. Before that, I'll just like to mention one thing. We'll just give names to these particular dimensions. These names which will be used in the variable pattern, so that we get a better clarity as to what dimensions we are changing. So I'll just double click on it and say width. I've already changed the names of particular dimensions. Here you'll see I've given the name thickness and similarly the X and Y position. So this is particularly helpful when I'm creating a variable pattern. So I go to variable pattern and select my features. So in the table, I can select particular dimensions, and here you can see a column has been added for that. And I add any number of dimensions like this. So now we have to create the instances. So from this add instance option, I can just add number of instances which I want. I can directly change any dimension from here. Example, I'll just give it 50, and I can just select this box, drag it, which we have in Excel can be used in this variable pattern. So the width you can see is incremented by 3 mm. The initial is which we created is 12 mm and it goes on increasing to 15, 18 and 21. Similarly, I can change my X position and Y position. Update preview. Just increase the dimensions a bit more just to get a better clarity. And just right click on a particular row and delete it if you want. So you can see I've increased my width, changed my X position and Y position. I can change the thickness as well. Similarly, I can add number of instances. I can set and change each and every dimension of it. Also, as we create number of rows as an option to skip as well. So I can select particular instances which I don't want, and this automatically will be skipped. And I can use this two options over here. If I have a file created in Excel, I can use import from Excel and use that file or the variable pattern. I can use this particular table that I've created. I can export to Excel as well. So here you can see I've created one more instance by increasing all the dimensions. It is very customizable sort of pattern wherein you can have control over all the dimensions of your parent feature. So moving on, we have completed the part level patterns. The assembly patterns are very much similar to what we saw in the part patterns. There is a slight difference. We'll see. Example, we'll see what linear component pattern does. That is similar to our linear pattern which we use in part level with a slight bit of difference in it. So here I've created a simple assembly with a counter bore hole, and I've just mated my this part in one of those holes. So by using linear component pattern, you will find it on the assembly tab. Select the linear component pattern. All the functionalities are same as we saw in the part level. And select the edge as direction 2, and keep the spacing and the components to pattern. I'll select my pattern. I'll keep the spacing to 80 mm. Here you can see the patterns are being automatically being mated in those particular counter bores. Similarly for direction 2, the spacing is 60 mm. only difference between options using part level linear pattern and this linear pattern is this option, rotate instances. So we'll see what this rotate instances does. I'll just show you with an example. This rotate instances option was a what's new feature. It came in 2018. I'll show what it does. I'll just open this sub-assembly and here you can see we have already created a linear pattern of the tree stand. We will use rotate instances and select this particular circular cylindrical face. So as I increase the number of instances, you will see the pattern, the instances are rotated along with a linear pattern. So as I increase the angle, here you will see how the tree stand has been rotated. So it is creating a linear pattern as well as it is creating a rotating instance as well at the same time. This was a particular what's new feature in 2018. Circular pattern is again similar to what we saw in part level. All the options are similar. You just the difference is that instead of patterning features or bodies, you're patterning the particular components in an assembly. I'll just move on and I'll show you what pattern driven and chain driven pattern does. So pattern driven is basically creating a pattern based on the existing patterns that we have. So we'll see an example for it. So here I have a simple assembly. I have a wooden plank over here and I want to pattern it. See here, you can see the holes over here. I want to pattern this wooden plank, this plank on these particular holes only. So I just expand the support leg and show you there's a linear pattern created at the support leg at part level. So I can use this linear pattern to create a pattern of this plank. So we'll see how it is done. We'll go to pattern driven component. In the components to pattern, I select this component, and here you'll see there's a driving feature or component option. I'll just select that particular linear pattern from the feature manager design tree, or I can select directly this particular hole. We just select the linear pattern option, and here you can see it is following the particular pattern which was created in the support leg, and the rest of the options are being similar. You can skip any instances if you like, and the seat position you can select as to what position it is being taken into account for patterning. So this was a pattern driven component pattern where you can use a driving sort of pattern created at part level. Moving on, we'll see chain driven pattern. So here in this assembly, you can see I have two links and there's a path. So I want to create a chain path of this two links. First and foremost, I'll just on the visibility options, I want to view the planes so that I can select in the chain driven property manager. So as I open the chain component pattern, here you can see the first option that we have is the chain path. So I'll use the selection manager to select my chain path. I'll select a closed loop and I'll select the entire path. So there are three actually methods for creating chain paths. There's distance linkage, and there's connected linkage. So for now we are creating a connected linkage. We can also create a distance where we can just select number of instances and specify the distance what we want. For now, we'll just create a connected linkage. So you'll see there are two chain groups available because it creates a chain pattern of two linkages. In the chain group, I'll select this first link. Here you can see it is asking me to select a particular reference axis for link 1. Like this is like a sprocket. So it is asking me this axis. So I'll have to select this axis. And similarly in the preview section here, you can see what exactly, which axis which we need to enter. Similarly, I'll select the second axis and the path alignment plane. So this is the alignment plane. So if I select this plane, accordingly the link will be centered along this plane of this path. Similarly, for chain group 2, I'll select this pattern, select the link, and again select these two axes. The alignment plane to be the center plane. Here you can see in the preview, we have got some, because I have only set 2 instances, as I increase, the instances will increase, or there's an option to directly fill the path. So if I select fill path, so entire path will be filled by the 2 links. Then I'll say OK. So this way I have use the chain component pattern. This is very simple. You can just instead of using connected linkage option, you can use these 2 options as well for a similar component and with multiple links as well. So the sketch and curve driven pattern, both are similar to what we saw in part level patterns. I'll just show you what the property manager options are. So here you can see in the curve driven pattern, the only difference that we see is the reference point has 3 options. One is bounding box, the component origin, and the selected point. Bounding box center, we can select the reference point to the bounding box center of that particular component, or we can select the component origin, or we can select any particular point which we want to reference. The rest of the options that we have, we can select the direction, the curve that we want to pattern. The only difference being instead of features, the components will be patterned. And similarly, the sketch driven pattern, we have to create a particular sketch with points in it, and we can select the reference point to be bounding box center, component origin, or a particular selected point. The rest of the options are all similar to what we saw in the part level section. Lastly, we have the mirror components option. Let's see how you have to use mirror components. So I have this assembly. I can use the mirror components by either just specify a plane about which we have to mirror and select this particular left side hub, the subassembly to mirror. So if I want to mirror this assembly on this side as well, I'll use the mirror components. Select my mirror plane. I'll select the right plane and the components to mirror. Automatically the left side sub has been selected. Just click the next option and see what are the number of options available. So there are 4 types of orientations. Depending upon the orientations which we desire, we can set the orientation, and the mirror type we can set to the bounding box center or the center of mass. Below there's an option to also create an opposite hand version. I'll just select that. As you can see in the preview, this nut has been is on the outside. As I click the opposite hand version, if I uncheck it, the nut, whatever the rivet, is on the outside. I'll just use the opposite hand version. And in the import features, I can select what features I want to import from that particular sub-assembly. And just say OK. So here you can see in this way, it is very simple to create a mirror component at assembly level. So we have come to an end to the webinar of this patterns on parts and assemblies. I'd just like to know if there are any queries or any doubts that you have. I'll just wait for 5-10 minutes just to see if you have any questions regarding what we have discussed in the online training. If you have any questions, you can either chat and explain your query, or you can even use your microphone to just say if you have any sort of queries regarding the session which we carried. The entire the video link of this webinar will be available to all if you wish so, and also it will be uploaded on our YouTube channel, that is Adonics Technologies. So you can also access it on YouTube. If you feel like you have missed anything, you can access that video anytime you like. If you have any queries, any sort of questions regarding it, you can just contact me, or you can contact support@adonics.com. I'll just wait for 5 minutes. Oh yes, Mr. Dinesh, thank you for appreciating it, and definitely it will save your designing time. As you saw, there are a number of options available in the patterns, and I hope it definitely helps you in your designing work. And we are really proud to serve all our customers and just help with such webinars in their designing work, and just make better use of SolidWorks for them. So we'll wait for 5 minutes. We'll see if you have any questions or any queries regarding, you can just send a message, or you can also say it. Yes, it's our pleasure, Mr. Vinod. That is our work, which to serve our customers better, and always give them something new and something productive that will help them in their designs. Thanks a lot, everyone, for joining in this session. I hope it will be helpful to your designing, and it will really prove beneficial to your future work concerning patterns. Just if you wait for a couple of minutes, if you have any questions, I'll just wait here for that, and then we'll just end the session. You can, as I mentioned, you can find this webinar on YouTube on our Adonics channel. You can anytime access this entire webinar on the YouTube channel, and if you have any queries, then surely we are there to help you and resolve all your queries. Thank you. Thank you so much, Mr. Jay, for attending. So I'll just end this session. If you have any queries, you can, as I mentioned, you can always contact us at support@adonics.com, or you can contact me as well, rishikesh@adonics.com. I'll just end this webinar and thank you all. Thank you so much for joining this webinar. I hope it proves beneficial to your designs, and also it improves your designing efficiency as well. Thank you. Thank you so much all.